So what we are going to do is we are going to talk about lists, okay? Specifically the ArrayList and LinkedList and how to use those and all sorts of really cool stuff. So let's go ahead and get started. So first off, let's create a brand new class. I'll call this list demo. So I'm going to kind of start off kind of where we were last year, looking at ArrayList. Before I do, well, if you look at the ArrayList class definition, you'll notice a couple things. Number one, it has these angle brackets with this E thing right there. And then you'll also notice that it implements the list interface of type E. So E is, this is template notation, which means you can put, so this is what's called a template, any class right there. Now it has to be a class. That's a big idea. You can put any class. So an array list is an array / list of whatever things you want to make it about. It could be dogs, it could be pirates, it could be dog pirates, okay? But it's fundamentally going to look something like this. Well, technically whatever you create will be a reference to a structure that's going to look like this with 0, index, 1, 2, 3, 4, and so on down the line, okay? And then what's over here are going to be references to whatever class you have, okay? So it's going to be references. That's really crazy. Stuff like that. We can see it implements the list interface. This documentation doesn't specify what the list interface is, but it's basically like add and remove and like some other stuff like that. So there's, and let's go ahead, if you look down there at all of the different methods inside ArrayList, you can add, you can find the size, there's an iterator and a list iterator method, which are pretty much outdated at this point because of the for each loop, or that is the enhanced for loop. So we're not going to pay too much attention to those. Get, set, add, and remove. So, and we're going to walk through these very quickly. The big idea with an array list is that it's an object. And so the way that we talk with objects are how, class? How we talk to objects? Through their, not through the parent, with their methods. Through their methods, that's how we talk, that's how we interact with objects. With an array, we interacted with an array with those brackets, but this is not an array, this is an array list. It's an actual class. So anytime that we interact with the array list that we create, we're going to have to use the dot and then put the method at the end. That's just sort of a big thing to remember. All right, let's go ahead and get started. We'll create an array list. Maybe just called nums. Oh, I got the brackets, I'll put int right there. Equals new array list of type integer, of int. And already you can see I'm getting some errors here. I put int right there. Syntax error, dimensions to complete reference type. That makes no sense. All right? There's something very plain I hinted at a minute ago. Why can't I use int right here? You have to put a class. So this is one of the main reasons for the wrapper classes is so that we can use integers and whatnot in these data structures. All right. And this is giving me a little bit of an error. It says ArrayList cannot be resolved to a type. I'm going to go here and say import ArrayList. So import java.util.ArrayList. Sometimes it's helpful just to do import java.util.star, just import that whole thing. Now, there's some really cool things about array lists. One of the coolest things, if you remember, is that it grows. You don't have to tell it its size at the beginning. Okay? In fact, at this point right now, all of this other stuff is wiped out. Okay, I'm not going to erase it, but we don't have anything even in the 0 element. It's just a completely empty list. The way that we add items is, yep, you guessed it, nums.add. 5. Nums.add. 2. But not add all. Nums.add. 4. Nums.add. I don't know why it keeps going add all by default. 1. Other things that I can do, I can add something at a specific location. If you look there, we've got the add int index and e item. I can say nums.add, add all, that's pretty annoying. So we have 5241, 5241. I can go in and specifically say I want to change what is at location 0. I want to change that to 10. So I can say add at position 0, 10. That's the add int index e item. I can, now what's the return type on that one? Do y'all see the, what's the return type? Look for the add method that has 2 parameters, the int index and the e item. It's towards the end. Void. Void, it's not going to return anything. So it literally just overwrites it. But if I do nums.set, and I want to set at position 2, I want to set that to a value of 3. So, if you look on the documentation, what's the return type of set? E, which is whatever the type that this happens to be a list of. So the set is going to overwrite it, but it's actually going to send back to you what was written there. Okay? So right now I'm not saving it at any location, but if I wanted to, I could do something like this. Int temp equals nums.set23. And what that would do is it'll grab at whatever is in position 2, which happens to be a value of 4 here, and but right before it totally deletes it, it will, it has it in a variable, it overwrites it with 3, and then it sends back the 4, so that 4 is not completely gone. Myself as the programmer, I can choose what I want to do with it at this point. I can do nothing, or I can, use that for some other values. So if someone says like, I want to change my password or whatever, you can use the set, and then maybe this would send back their old password or something like that. Why you won't do that in particular, but or you can just do nothing. You can not save it. All right, there's the set, and let's go ahead and print everything out. So you've got 2 ways of traversing through array list. I can say int I equals 0, I less than nums dot size I plus plus system.out.println nums dot get I. That's using the traditional for loop. And you can see I've done a couple other things there. I've demonstrated the size method and the get method. What is the size of this particular array list, gentlemen? Go, Jeremy. We do. Did I make a mistake there?
Yeah.
What'd I do?
Well,
10, 5.
When you added the 10, it actually bumps everything down.
It did. That's pretty okay. So it did. So add. So you're saying this add right here literally adds it to position 0, and everybody else gets bumped. Okay. So it add the 10, and then we've got the 5, and then there was a 2, but I overwrote that with a 3.
Yes.
And then there's a 4, and now you might say, why are you putting this arrow and then having this in a box? And I'm like, well, actually, this is a more accurate way of putting it than putting just 10 inside there, because remember, this is an array of integer class objects. Okay, the class integer, and so actually each one of these is a big I integer. So the size is, you said 5? Agreed. The difference is with the arrays, if you remember, you use the dot length. But with ArrayList, we use the dot size method, which gives us the size. And you can see here we also have get, where that just simply gets whatever's at that index. Another way that we can traverse the array is with a for each loop. So we can say for each integer I in nums system.out.println I. And remember, we say that for each integer I in nums. So and you say the for each at the beginning, and then you say in where there's the colon. In case you're wondering what that iterator and that list iterator are all about, before the for each loop, if you wanted to walk through one of these things, this is part of what's called a collection. This is a collection of things. We will find out that there are other ways of having collections, some with different rules and stuff like that. Like we'll talk about bags and stacks and queues and linked lists and things like that. But this is a collection. If you wanted to walk through or traverse a collection, you had to create another object that was related to it, and it was called an iterator. And the iterator would essentially point at the gaps in between the elements, and you would have to say something like, all right, I want to create an iterator for this list. Iterator, give me the next one. And it would say, okay, here's the next one, and it would give you whatever this value was, and then now the iterator would be pointing here. And you can say, iterator, give me the next one, and so then it would give you the next one, and then it would point sort of right here. It was never actually really pointing at the object. It was kind of pointing between, because then you would say, does it have a next item? And if it did, then you could say, give it, send it to me. And if it didn't, anyway. So, but the thing is that got really cumbersome and actually quite annoying. And they just said, you know what? We've got this process involved. If we were to actually scroll back and kind of look at the code that's going on behind here, that's exactly what this is doing. It's creating an iterator. And if you guys want to take programming 3 next year, then we can explore all that fun stuff. But you don't need it for UIL. You don't really need it for this class. It's sort of an older thing. When you get to the point when you're creating your own structures and you want it to be able to utilize this, now that's where it's getting pretty cool. When you create your own collection class and that other people can do this stuff for, then you've got to have the iterators. But we're not going to worry about that right now. Does that work for y'all? Side note, I know I put integer right there. Because each one of those are integer objects, I could just as easily do int, and Java will do the auto unboxing. If you remember that, where it unwraps it, takes it out, and stuff like that, it will do that automatically each time, which I think that's pretty darn cool. So, all right. But you'll see here that there is something terrible about my list of numbers, and that is that they're not sorted. Okay, and if you remember at the end of AP Computer Science, we talked about all sorts of different sorting mechanisms that work with things like quick sort, merge sort, and bubble sort, and yeah, they're a big mess. The thing is that you could write those yourselves, but why bother? Other people that are much smarter than all of us have done that, tested them, and they have provided within the Java language a mechanism to sort this just like that. Okay? Now all I have to do is call a method. And that method is in the collections class. So you say collections dot sort, and then you'll put in parentheses nums. And I'm going to put here sorted. And there it is. The list once it's sorted 1, 3, 4, 5, 10.
Is there a different way you can sort it, or does it automatically numerically choose lowest to highest, or can you reverse it?
Great question. Great question. Love it. How does it know how to sort them? Right? And the answer is that this class that you choose, in our case, it's integer. Okay? That we have our array list of. The sort mechanism calls the compare to method on each one of them. Okay? If you remember, there was the comparable interface, which if an object implements the comparable interface, all that means is that it has one method called compare to, in which you compare one object, one instance of that class to another instance of the same class, and you return a value either negative if it's before, or 0 if they're the same, or positive if it's after, right? Well, the people who wrote the integer class also wrote a compare to method within that integer class. And the way that they chose to compare integers was the one that's smaller is the one that comes first. It just makes sense. And so that's how they did. If you want it to sort in descending, then you're going to have to write that yourself. But it's whoever, it's the class of which the array list is a list of. The way that its compared to method is implemented decides how collections.sort is going to run. Is that a mouthful enough for you? So the compared to method is the one that decides that. And it's the compared to method inside the integer class, and that's written by those people. Jeremy was asking me the other day about something similar with arrays. And just in case we had an array, like if we had int, bracket, bracket, an integer array equal to 10, 8, 7, 5, you could sort this array automatically with the snap of your fingers. It would be, right there by this. You'd say arrays dot sort, and then you can put the array inside there, and it'll sort it. And that too will bring a smile to my face and to yours, because it'll be sorted. All right. Other questions? Nope. All right. Oh, there's one that we method we need to talk about, and that is remove. And I know we did this extensively. Let's go ahead after we have them sorted. I'm going to comment out this original. After we sort them, let's say nums dot remove. Let's remove the one in position 0. Now, who remembers the trick about remove?
Just gonna take the one spot and everything goes back up.
And everything goes back up. That's right. Everybody gets bumped.
So in theory, our add and remove is going to take each other out.
Say that again.
So where you added the 10, the remove's going to remove the 10. So you basically cancel the same workout.
Well, no. Good point. When I sort it, it actually literally rearranges them in the proper order.
Oh.
So this is now the 1. This is the 3, 4. This is the 5, and that's the 10.
Got it.
So when I remove what's at position 0, and I say after remove, you'll see we've just got 3, 4, 5, 10, which is exactly what we would expect. Okay, Nick, any questions? Cody? That all should be kind of reviewed for us, right? This is called an array list because what's going on behind the scenes is there's an array. They actually have an array that's keeping this data. Yes?
What is the Boolean?
That's the add that we used before. You're saying why is it Boolean?
Mm-hmm.
It returns true if it was successful adding it. You might say why would it be unsuccessful? Maybe if it ran out of memory. That's probably about the only type of situation I can think of. So, yeah, that's all of those right here are actually secretly returning a value of true, but I'm not saving it, printing it, or doing processing it in any way. I'm just letting it fall. Good question. So behind the scenes, there's actually an array. What they did is they created a class. Literally, what this is wrapped up with an array with the inside, plus all these other methods like the add method and the remove method are ways that outside classes can interact with this black box. We can't reach in here necessarily manually and change them unless we follow the rules in terms of I don't know what would happen if we would say try to remove something at a value that doesn't exist. Have we done that? Makes me wonder now. What happens if I were to say remove and put in a number that was greater Like what if I said remove -1?
Might throw an index out of bounds, though, wouldn't it?
Yeah, array index out of bounds. Oh, move that back to root 0. Problem. So, anyway, we'll talk more about this later on about actually how they do that, because one of the challenges that we're going to do, we'll start working on together, but then I'm going to leave, I'll do part of it and you'll do the rest of it, is you actually will write your own ArrayList class, where you'll start with an array and then you'll add some other methods onto it that allow it to begin to work like this. It really helps you understand more about what's going on here. Okay? But there is another list, and that's the linked list. So this is class linked list of type E that implements list E as well as Q E. You're like, Q, what the heck is Q? Well, if you let your eyes roll down here, a couple lines, you can see interface Q, which then they don't tell you anything about. They just say, there you go, interface Q. So the linked list has some interesting items. It has an add first, an add last, a get first, a get last, and a remove first, and a remove last. And you're like, okay, so we can add things at the beginning, and look at the beginning, and we can add things at the end, but what about the middle? And the answer is, yeah, you really can't mess with the middle. That's kind of hidden from you. You might be like, why in the world would we want to do this? And the answer is, because there's some extra overhead that comes along with arrays. You can't see it, but there's an array behind the scenes here on this array list, and anytime you want to add another item, it actually has to go in and create a new array, make it even bigger, copy all of the old ones down, okay? And then it has your array list. You're like, yeah, but it just grows automatically. Yeah, it doesn't grow automatically. Someone had to write the code to make it grow. And the way they have the code that makes the array grow is they create another one and they have to copy all those values down onto the new one, and this one's just got one extra slot in it. What if you add another one on there? Well, what they do is behind the scenes, you can't see it, but they have to actually create a whole other array that's one longer, copy every single one of those values down onto it, okay? And then you've got it, so it starts off with array size 0, then if you add 1, it's array size 1. If it's array size of 50,000, which is very possible in some situations, and you want to add another item, it's got to create a new array of size 50,001, copy all of those 50,000 down. Okay, so for the type of stuff that we're doing, we are not necessarily going to see the performance drop that you get with an array list, but there is one. Okay? So the way that the linked list works is it doesn't have an array. The way a linked list works is it's going to create the reference. And that reference just points to one object. There, it also is going to point to the tail. The head, whenever you add another item, is going to point to this item. So let's say I can put the number 5 in here, but this is what's called a node. This node points to the next node, and that node has maybe a value of 3, and also can point to the next node. Maybe this one's a 1, and that node maybe points to 10. That one doesn't point to anything. And the reference has a reference to the head and to the tail. And so you can get information about the beginning or about the end, but you can't access any information about the middle. Not like you can with an array list. Okay? And you might say, well, that seems kind of stupid because I can't do as much with this. And the answer is that's right, you can't. But if you want to add one more, all right, it's super easy. It doesn't have to go through and copy all, create a memory space that's exactly as big, but just one slightly larger, and then copy each one of those values down, and then add to another one, okay? Yeah. If you want to add a new item, all you have to do is just has to add one on here, and it's that fast. So when you get to really, really large applications with lots of numbers and things like that, adding another item on here, you do not have that performance drop. You do have a performance drop if you need to find one of these middle terms. If you say, I want to find the third one, or the second one. Well, if you need to find the second or the third one, then it's going to have to go through here. 1, 2, 3, or 0, 1, 2. It's going to have to go through and count. And that can be slow if you have 50,000. Okay? Adding stuff onto the ends, super fast. Looking in the middle, can be super slow. Over here, finding one in the middle, that's super fast. Adding more to the end, super slow. It's a trade-off. And like I said, you're not really going to start seeing those performance drops until you're in the thousands or in the hundreds, but what the objects maybe are much larger than just good old integers. Okay? I really don't need any of this code anymore, so I'm going to delete it, but you might want to hold on to that code. That's not what I wanted to do.
I think your Eclipse crashed like mine did.
Maybe.
See if yours does this.
So I'm going to say linked list integer I'll make one num list equals new linked list integer. So a linked list is another collection. We're going to be discussing stacks, queues, sets, maps, graphs. All of these are different types of collections, different ways of storing data and accessing them. Does it make sense why it's called linked list? Because of the links. So we can say numList dot add first, and I'll try to make it look like that linked list. So 5. Numlist dot add last. Add last. 3, 110. 3. 1. 10. So, to traverse a linked list, we could say we use a traditional for loop. I think I'm not sure on this one actually. Numlist dot size. Yeah, we've got size. I++, and then we can say numlist dot get. No, wait a second. It doesn't have get listed here, but it does have get available, and I can say get I. Now they're not going to show you how it's going to get I. No, wait a second. No. they're not going to show you how they're going to get I, but the way that they're going to get I is they're going to have a counter that's going to go through here until it finds, I'm looking for the fifth one, 0, 1, 2, 3, 4, and that's how it's going to get there. And I want to wrap that in the print line. Fundamentally, we can see there's not a whole lot of difference there. And there really isn't. I mean, from the user standpoint, we don't need to know all the details about what's going on behind the scenes. We just need to know we've got a list in somehow. And there's a lot of commonality between these two because they both implement the list interface. So anything that's in the list interface, this one can do. If I went, so we looked at add last, add first. I think y'all can understand what get first and get last are going to do. They're just going to get the first one and the last one. And then remove first and remove last. And those are pretty straightforward. It's going to remove the beginning or it's going to remove the end. I'm going to dot remove first. What's interesting, and when we create one ourselves, it's really kind of fascinating. The code that has to go on when you remove the first. Because if you just say, all right, I'm going to delete this, then you're like, wait a second, where's the head? There's no one, I just deleted the head. There's no one that's going here. And so what has to happen is while this one is still in existence, you have to say something along the lines of head equals head dot next, so that the head reference is now pointing to this guy. And then you can go through and delete this one. Now, the head is pointing to the 3, and the 3 is pointing to the 1, and the 1 is pointing to the 10. Does that make sense? Each one of these is the next variable. Also, it's interesting what happens when you eliminate the tail. If you try to eliminate one in the middle, it gets really kind of messy, and we're going to get our hands dirty, and we will build this ourselves from the ground up. It's actually a lot of fun. You really get into some of the code. It's one of the sort of things that all programmers have to do. But before we dig that deep into this, I want to make sure that we understand what's going on, behind, sort of we need to be able to interact with this before we can worry about how to make it our own. Okay? So, I removed the first, and now I'll show you, once again, we can use a for each loop to walk through this. We can say for each integer I in numList system.println I. And I'll tag it here, println removed. All right, and so there's you can see the remove. First, literally did remove the 5, and so now we just have the 3, 1, and the 10. Okay. I don't expect you to fully understand. Hey, y'all. Stop giggling. All this stuff, because, like I said, we haven't written this. When you will understand it when we create our own. okay? But we're gonna cover the rest of this sheet and utilize some of these before we do. Are we in order, 3, 1, 10? Oh, we're not. Okay, so we can do something else. We can also do the collections dot sort num list on that, and it will sort the list. All right. So today we talked about lists. Somebody tell me something that you learned.
The sort.
Learned about the sort. Pretty powerful. Dylan, how about you?
The sort and how it decides, or who originally decided, or who attended to make the order go.
Okay. Nick, something you learned? What? Sounds good. Jeremy, what about you?
I learned that there is a waiting list.
That's right. Didn't even know about it. Now you know.
Guess we're done.
Yeah, go and kill it.